Okay, the reason we're keeping this one highlighted, if you see the little 4 points there, is so we can know what exactly that part of the wall measured. I would go back to takeoffs. You can see on here highlighted, I mean the main building CMU is highlighted. You can see all of them here. So since this one is the one highlighted, it's talking about this section. You can put your cursor on top of it, and that one says it's 974.783 square feet. Let's say what this one, man, this is just one part. That one would be 607.554 square feet. But if I put the cursor on the main one, it tells me what all of that block is, which in that building has 12,405.587 square feet. To find out how many blocks to get the amount of blocks you need for a certain area, let's take this one. This one's a little, it's just square. This one says it's 974.783 square feet. So I would round it up to 975. On my calculator, I would do 975 square feet times 1.125, which means I will need 1,097 blocks. I will need 1,097 blocks to cover this area. The reason you do square feet times 1.125 is because one block is 8 by 8 by 16, or technically the face of it is 8 by 16, which is 1.1, which is 1 1/4 square feet. Well, one block covers 1 1/4. And you can do it like this. Say you have 12 square feet, so 12 times 12 inches, you have 144. And then you have a block is 8 inches by 16 inches, which is 8 times 648, 128 inches. So you do 144 divided by 128 inches, and you have 1.125. So technically, one block covers 128 inches, and 1 square foot you have 144 inches. 12 times 12 is 144. So technically, you would need 1 1/4 of a block to cover 1 square foot. That's the reason for the 1.125 square feet times 1.125. All right, let's go back to our takeoff. Do you want to save changes to? No, we don't want to save changes to that one. And we're back to this one. And again, this one is not, is the below, is going to have some showing below grade. I've already worked this one, so I'll show it to you later. And since this is one of the main ones that we need, we'll do rename it. This is page A5, exterior. I just put elevations. You don't have Anna, you don't have too many buildings that have in that you will need the interior elevations. On the plans, you will always see them, but there's hardly anything that has to do with our work, except on the racing canes. The racing canes have one or two brick walls inside the restaurant, and so that's where you will look at the interior elevations. But in this case, it's we mostly do what I call shell buildings. They other people call, everybody calls them shell buildings. And that's just imagine a turtle. You know, you're the shell, the outside. Well, that's us working on shell buildings, just the outside, covering the outside. Uh, Lately, well, it's been about 2 years now that I've been doing a lot of structural buildings. The structural buildings consist of of the structural. Well, that's what it holds the building itself, the roof. And the reason I say that I'm doing structural is because we're building buildings out of block, which hold the roof, which holds the whole structure. But imagine the houses. I say 99.9% of the houses are built out of wood. So the frame itself is built out of wood. So that will be a wooden structure. Commercial buildings are built. Uh, you hardly have. You do have some, but you don't have too many that are built. The Taco Bells. Some of the restaurants are built with wood structural buildings. But most of the commercial buildings are either block CMU, which is CMU, or what's the other word? I'm sorry, the other structural, the metal. And what they do, they put metal beams at the corners and like every 16 feet or 16 inches, not sure. Uh, and then on top of that, they put um, they call it ugh, dense glass, which is like plywood. It's a different kind of plywood, man-made plywood. I guess it might have glass. I don't know. That's probably why it's called dense glass. Not sure. And in those cases, the structural is already there. So we just go in and put a. I'll show you all of that on the Racing Canes, the Taco Bells, the uh, most of the other buildings. We're working on one in San Marcos where we put in stone. The clinics, all of that, they have, you'll see brick and stone, but we're not responsible for the structural. We're just covering the shell per se. And but the CVSs that we're working on right now, they've been giving me a lot of work with them because they're made out of block, and so we're doing the structural on that one. But most of the time we're doing just veneer. With just imagine veneers, what they call on what they call those fake teeth. To when you got really crooked yuck mouth teeth, you put some veneers, and the following day you got straight teeth. Well, that's same thing on this. The building is gonna be either wood, metal. Either one is gonna be covered in by dense glass or plywood, and then on that they add what is called the wet waterproofing, so the water doesn't damage it, or the moisture doesn't get to it, and shorten its life. So on that they put the waterproofing, and the waterproofing, you're gonna hear it referred to as Tyvek, because that's one of the biggest companies that sells that. You've seen it where they're working on a house or a building, and then it has like white plastic on it. Like they just staple it on there. That's the Tyvek waterproofing. And that when once they set that on the building, then that's when they call us in to go ahead and lay the block or the stone. We have to leave a 1 inch air gap on full size brick or full size stone. You also have what they call the thin stone, or thin brick, and that's just a veneer. On those, once the building has been waterproofed, we stapled what is called. Uh, uh, I have them all on here. Uh, we put what they call yeah. Give me a minute. Um, New Braunfels. Let me see. I'm trying to remember one building that I've worked on where we had to put this. Let's see here. Christian Brothers. Yeah,